Hello Airsoft Commando, I see you came again to have a look on your rack. Oh wait, what is it? HK416 A5 GBBR from UMAREX VFC, nice. It suits your style. It is tactical, reinforced, ambidextrous, dark earth, close quarters battle, modular, licensed, compact, lightweight. But hey, isn't it known for having notorious issues with bolt catch? You must have heard it. It fails all the time. Hey you, stop acting like an Airsoft Commando and start behaving like a man. You've got a problem, then solve it.
But Frog, how can I do it?
With the unlimited power you were given, like the whole humankind when you were born. Use your brain and start to think.
Oh, thank you, Frog. You always know how to help.
As you know from the intro already, HK416 family and in general or all AR-15 family based GBBRs from VFC, the latest generations, they might have a tiny issue with the bolt catch, not catching the bolt carrier group after the last shot. Although in regular designs, I mean HK416s and AR-15s, is not that visible because the bolt catch geometry is kind of simple. In HK416 A5 this is really visible and annoying, so it happens almost all the time. So it happened to me too. You can see this is of course a GBBR. And it happened to me too. This gun was having a real bad issues with the bolt catch, and they started after running it for like 5,000 rounds or something. Earlier it was not that visible, but of course if there is something not working in the GBBR, then Frog Engineering has to investigate and improve it for the sake of world's airsoft. Today I want to show you how to solve this issue, and this is the best solution possible in my opinion, because I tried everything that is available on the internet, also on YouTube, and nothing really worked. So I completely disagree with those upgrades. Some of them actually impair the functionality of your gun. I will show you how to do it and have a fully functional gun. Of course this one is converted to HPA, so you can say that it's different, but actually it's the same, because this conversion to HPA works the exact same way as the regular green gas magazine would. It's just that the gas tank is attached permanently to the gun instead of being a part of the magazine, and the magazine is separate. That said, let's start. There will be two issues that I identified, and the first minor one goes, let's say, first. So let's have a look. First I will remove Frog Engineering magazine, and I will explain one more thing. So in this gun, bolt catch works exactly like I said, like in a gas magazine, only the levers for the mechanism are inside the gun, not the magazine. You can see that the magazine works similar to a gas pistol magazine. It has a component that pushes on the bolt catch here with this small arm on the side when the BBs are out. So it goes up and lifts the mechanism in the gun, making the bolt catch stop the bolt. So it's exactly like a regular GBB works. The only difference is that here we don't have the gas tank, it's empty, and the gas tank is permanently in the gun. And now I will open the gun to show you the first issue. This is nothing tricky, I think I don't need to really explain it. So one pin here, second pin in the front, and it's opened. We don't really need the upper receiver for this one, so let's take it away. And let's have one more look at the conversion. So you see that the gas tank is here, and there in the window you can see this tiny lever, which is the bolt catch mechanism. If I now take an object like a screwdriver and I lift this lever from the inside, you will see the bolt catch here move. So up and down, up and down. How do I find the issue then? First, I took the magazine, because obviously if the bolt catch does not catch the bolt, it means that it cannot for some reason move upwards when it should. And this movement to the top is actuated by the spring in the magazine, in my case through this orange plastic element. So the first thing I did is I inserted the magazine and I was looking for any issues with the mechanism moving. So of course it's spring loaded now because the magazine is empty, and I was looking if there is a position, for example if I stop here, that the bolt catch will not move. But you can see that if I stop it on the bottom, the bolt catch jumps to the complete top. If I stop it, for example here, it moves anyway. If I stop it here, it will lift. So this indicated to me that the strength should be okay. There must be something different. Because I cannot check how the spring actuates the bolt catch, like it does it automatically, I cannot measure the force or something. I took this screwdriver again and I tried to push on the mechanism and move this mechanism back and forth, trying to find if there is any tension or like increased strength needed at some moment when I push on the levers, so that this could be some obstruction to the movement of the bolt catch. Yeah, so now I'm lifting it. In my case there is no obstruction because I removed it, but this is exactly the first failure I identified. So you can notice that this is true actually for any VFC AR-15 type GBBR. If I move the bolt catch, if I try to rotate it to the sides, you can see it actually has a lot of clearance. And in this gun and two other guns that went through my hands, the regular 416s, in all cases the bolt catch was so loose that it could go over this cutout here and then get caught on the body, which increased the force needed to move it. It had to slide off the edge here underneath. I will show it in a moment. You can see that the bolt catch has this chamfer underneath that should prevent this from happening, so it should easily slide off the body. But because it's so loose to the sides, it can be rotated so much that actually this chamfer will go over body here and you will feel a little resistance when trying to push this up. So this is the issue number one, which is easy to solve. You just remove this completely, so the spring, the pin and the bolt catch, and you need to file it off a little here from this edge. In my case it's already filed, so I'm not really able to show you how it looked before, until you get to a stage when you rotate the bolt catch like this, so the button goes to the rear of the gun. It does not catch again against the body. It's just going loosely downwards, pushing on the spring. In my case, as I already said like 3 times or more, it does not get caught because I already did it. And it's very easy to try if this could happen in your gun, even without HPA conversion, because you just need to take off the upper receiver, catch the bolt catch in your hands basically, move it like this to the maximum and then slowly start pressing it and see if it gets caught on the body or not. If yes, then number one improvement you already know. This one is very simple. I know that people often remove this tiny little spring that was here inside, but when you remove it, in my case it was actually not helpful, and this impairs the function because it has to push the bolt catch back when you charge the gun and the magazine is full. So if you remove this spring, the bolt catch will be completely loose. One thing is that when you shoot the gun and you point the shell ejector to the top, it will start, the bolt catch will start to drop and it will start to catch your bolt unnecessarily. And the second thing is that when you try to reload the gun, let's say the real steel way, if I have the gun laying on the side, the spring is in right now, so if I pull the charging handle, the bolt catch will go back. This would not happen if I would remove the spring, the return spring. And here you can see that this edge is actually a little round because I filed it off to take so that the bolt catch will not catch against it. So now let's jump to the second item, which is the most important one, because although I did this improvement, it helped a little, but it did not solve the issue. It was repeating very often and it was really annoying. So to understand the next one, what we need to do is to actually understand how this gun works. To show you the solution to this issue, I need to replace the original bolt because this bolt assembly is modified not to have the problem, with a new one. So this is brand new, fully functional, straight from the shop. I will put it into the gun. So let's understand how the bolt works and how the bolt catch works. When you pull the trigger, the bolt, after the round leaves the barrel, will start to move backwards. And you can see that the nozzle stays in place. And it stays in place quite long. And this is to have a good sealing and no air leaking. So if you have a good, well-assembled GBBR, this should happen, that the nozzle stays for a long time when the bolt moves back. Yeah? So there will be a point in which this nozzle will be released right now. So you see it moved back. Let's do it again. So the nozzle stays, it stays, and almost at the end of the cycle it goes back. This is a good sealing in the gun. So in this case, when the bolt is fully back, we want our bolt catch to go up and catch it. I'm of course moving it with my hand. So you can see that there is some clearance to it. So if I push the bolt catch with my hand, if the bolt is not yet there, you will see that it will catch not at the very end of the movement, but a little earlier. So it catches right now. So the bolt is like this. The bolt catch already can catch it, but the bolt has some free movement. You can see I'm able to move it. This is the next test I did. I was pulling this bolt back, trying to see if there is no problem that because of small force on the spring or something like this, this bolt catch will stay, because maybe it sometimes moves up when the bolt hits against the stock and there is some vibration going on and the bolt catch sometimes open or sometimes not. But I was not able to find such a position that the bolt catch would not catch. So you can see that I'm moving this and the bolt catch goes fully upwards and it always catches at the complete top position, in the very top position. I tried another thing. I took the magazine apart. I tried to squeeze the spring even more to some ridiculous strengths. Yeah, I put the BBs under the spring so the spring pushes harder on the bolt catch to make sure that it has enough strength to always catch this bolt, and it never really worked. So nothing I did was okay. So if this is not the case that there is some collision, and this is not the case that we are lacking the force coming from the magazine, what could this be? And the answer is kind of simple but tricky. I started to look on the bolt catch itself. So you can see this is the original bolt catch I took out of the gun, and I painted this silver surface because I wanted to know if the bolt even engages it. If the paint would be removed, it would mean that the bolt catch goes up, the bolt hits it and scrapes off the paint. And in my case, the paint stayed there, which meant that this thing does not even go up. And I already checked that I have enough strength in the magazine to move the mechanism, and I know that there is no occurance in the gun. So where the issue comes from? The next thing I looked at was the bolt assembly itself. So this one is the original one. You can see it's worn out a little. It ran for like 15,000 rounds, some more. I noticed that the nozzle actually it gets damaged. You can see this is not a sharp corner, and it's scratched very badly on the side. So I immediately thought, okay, so let's have a look where these scratches come from and how it's possible. In the gun, it works this way that the bolt catch goes here under the nozzle and the bolt assembly. When the bolt moves back, it can rotate and the surface hits against this steel insert on the bolt group and catches it in the rear position. So the only thing that the nozzle could be hitting at was actually the bolt catch arm. You can see I actually removed the sharp edge here to remove or reduce this effect, because it was getting to this opening for the gas and it would not be sealed if there would be a cutout here on the corner. So let's look again how it works. This is the original bolt now. As I said, when the bolt goes back, nozzle stays. It actually has some clearance, but is pushed against the seal on the magazine or the conversion, and the nozzle stays, bolt moves back until it will be finally pulled off this seal. And then the bolt is still traveling backwards and the nozzle goes into the bolt. But what apparently happens is that this arm of the bolt catch is lifted up before the nozzle gets hidden inside of the bolt carrier group. So you can see that the situation is that the bolt moves back, the nozzle wants to go back, but this arm already goes up. So when the nozzle finally returns, it hits against the bolt catch and it scrapes off the bottom of the gas inlet there on the bottom. This is the new bolt, yeah, so it's undamaged. So this happening was exactly the reason why I got this corner filed off. And it was happening not only in this gun, but in all the HKs I had in my workshop, because in all of them this corner was eaten out. So one thing is if the bolt works, bolt catch, and the second thing is that your nozzle is actually getting damaged by it. So I thought, okay, that's kind of complicated, maybe it's true, but you can see this is the original bolt catch and this is the new one, the replacement part. And have a look here, this one actually is different. Here it's more narrow. I also filed off this corner to prevent the eating up of the bolt of the nozzle, sorry. But you can see that actually it's already improved in the new part. The original is this one, so when it rotates, this top surface can scrape against your nozzle. In this case, is less material here, so when it rotates, it scrapes against your nozzle, but not as much. So VFC actually tried to fix this. That's a good thing. So I replaced the bolt catch with this new one. VFC did some good work trying to improve it, but again, it did not solve my issue. But this investigation allowed me to understand where the issue is. Because of this collision I just explained, bolt catch gets jammed when the gun gets reloaded and it cannot fully open or move to the top and block the bolt carrier group. And what to do about this? I noticed something, because if you know how the GBBR, the VFC system works for the AR-15, it has a, let's call it, double action valve knocker here. So when I pull the trigger, hammer goes and pushes, you can see it, it pushes on the valve knocker, right? This part that moves here. So let's try doing it. Yeah, so it pushed on it. And you can see that the valve knocker is inside now, but if I reload the hammer, the valve knocker did not go back. Yeah, and what you need to do in order to have it move back is to press on this lever, and now it jumps to the original position. So again, hammer hits, goes back, and you can see there is slight movement of the valve knocker, yeah, so it goes tiny bit backwards, but the gas still keeps flowing unless this lever is pressed and the valve knocker moves back. And on the bolt here there is this small cutout which works with this lever, so when the bolt moves back it will actuate the lever, pushing it down in a proper moment to cut off the gas supply. Yeah, you can see that this actually moves this lever quickly. You already heard the click, I hope. Let's do it again. So listen for the click. You can see I barely moved the bolt, it's like 1 centimeter, and there is a lot of movement until the bolt goes to the very end position. So this means that the gas stops flowing after like 1 centimeter or something of movement of the bolt. And that's really interesting, because this means that this effect of the nozzle staying for so long in the chamber is actually not so useful as you might think. So now again I have my original new unmodified bolt in the gun, and let's try doing this again. So I will charge the gun, and I need to cock the hammer first by hand because the noise will obscure how the valve works, and hear this. So I'm pulling this back and you will hear when the valve is released. Now, so you can see that the bolt barely moved and there is already no gas flow from the magazine or the gas tank in my conversion, and the bolt still moves back all this way, not pulling the nozzle out until this very rear position when the nozzle jumps out. The nozzle going backwards would already hit the bolt catch in the elevated position. So now the question, how to improve it? Let's force the nozzle to move back earlier. So instead of very end, let's move it in the half of the movement, because if the gas is stopped somewhere after 16 millimeters, then in the half it's more than 2 times more time or length of the travel of the bolt group to release the nozzle. I don't want to make the nozzle jump easier out of the chamber, because I will start getting random FPS and I will start having issues with constant shooting. So what I want to do is to make the bolt pull the nozzle earlier, not here. How I will achieve it? Actually, I will modify the nozzle, because if you look at it, this is a new nozzle. Here on the rear there is this screw on the top side, and the goal of this screw is exactly what you've seen. So there is a metal piece on the bolt assembly that travels in this groove, and when it hits this screw it pulls the nozzle out of the chamber no matter what. So what I want to do is to move this screw to the front and basically eject the nozzle with a hard stop from the chamber earlier. It will cause it to jump out when the bolt is in the middle of the travel. So it gives much more time for the nozzle to retract into the bolt before the bolt catch goes up and hits on this gas inlet. It will go up only when the nozzle is behind it and there is nothing to damage in this section. This is the way how it should normally work. I will show you now using this new bolt, the unmodified one that is in the gun right now, and I will modify it to this state that I have in this modified nozzle, where you can see that I cannot pull the nozzle more than only half. So let's take it out and let's print one part that is in the link of this video. You want this part to be as hard as possible, so I recommend printing this out of regular PLA. Let's do it and let's start working on the bolt carrier group. The first thing we need to do in order to make this modification is to take the nozzle out of the bolt carrier group, and for this reason we need to disassemble it. My bolt group is one of the newer versions. In your case it might be a little different, but anyway the modification will work for all the bolt carrier groups that you can find in any kind of AR-15 based VFC GBBRs. So the first thing that I will do is to remove this top part. I need a screwdriver to remove this big screw here on top. The screw is out. Then there are two more screws. You need small hex key in order to loosen them. You don't need to remove them completely, take them out, but at least loosen them. If they go out a few millimeters, it should be enough. Like this. And there is a pin going through this top portion here in the hole. Can you see it? Now you can see it, and you want to push this out too. So now what should be possible to do if everything was done properly, you should be able to pull this part back and remove it from the top. You can see that this pin was blocking this movement against this feature on top, so I pushed it far enough to enable this movement. And the last thing you need to do is to take out this washer that is there on the rear. I'll use a tiny screwdriver. So here it is, and now I can pull out the nozzle. To disassemble the nozzle, I'm using this hex key in this hole here on the rear side, on the bottom of the nozzle, to push out one tiny pin. Okay, so the pin is there. And now I can pull this apart. And let's throw everything outside. So you have the end pass, the silver part, and you have the return spring. Let's put this aside. We will be working only on this part of the nozzle. I'm gonna clean it with alcohol so that this remaining grease that is in here will be out. We will use some glue also, so it's good to get rid of it. And now when it's clean, I'm gonna insert this 3D printed part on top of the nozzle. It has this chamfered corner on this side. So this chamfer going backwards, you will see how it should fit when you have it in your hands. So the dimensions are such that if I put it here over the nozzle, it will be possible to push it in and down, and it should fit nicely into the nozzle. I can actually push it back as much as I can. So probably now you understand. I have this part here, so instead of this hard stop on the rear, I will use another hard stop on the front. The only problem is that the forces in the GBBR are so big that they will damage this plastic, so I need to attach it very, very firmly. And for this reason I will glue it in place, but I will also screw it in place. So for the gluing, I'm gonna use a quick drying glue. I'm gonna apply it underneath, from the front, from the rear. And I'm gonna leave it like this for a moment for this glue to harden. When the glue starts to harden, I'm gonna take a drill. It's 2.5 millimeter diameter, and I'm gonna drill one hole here on the rear side and one hole here on the front side. The front one has to be as close to the edge as possible of this printed part, I mean, because this would be the real hard stop. You can see that this part will be acting against it, like this, moving backwards. So I don't want this part to damage my new insert. And on the rear it's only for strength, so it makes no big difference if I make it exactly on the edge or a little more to the front. So let's drill it. As I said, this is 2.5 millimeter drill because I'm gonna use headless 3 millimeter screws afterwards. So this fits together. So in the rear, the easier one. The drill goes through, so I want to make a through hole here. You can see it. And now let's make the other one here. As I said, as close to the edge as possible. And again a through hole. And be careful, it's only a through hole through this top of the nozzle, not through hole nozzle, yeah? So you want to get the drill inside the nozzle. And I'm through also here. You can see the hole is there. And because we drilled the through holes, there will be a lot of debris inside, so I'm gonna take a round file and I'm gonna clean it up a little. Just be careful because the internal surface is sealed against the part that we removed from in here, and you don't want to scratch it all around. You just want to clean the holes. So now back to our nozzle. You can see 2 holes are there. The part is glued. So I'm gonna take M3 x 5 screws. I'm gonna use the hex key to thread them into these new holes I did. And when you thread them in, you make sure that they don't go into the other side, because they will obscure this part from being inserted. Yeah, so if they are a little above this plastic, then it's not a problem, we will fix it in a moment. And the second one. Now both screws are in, and you can see they stick out a little with this printed part. So what we want to do is to take a flat file and file this to make it even and make this upper surface of the nozzle round like it was previously. This one looks okay, let's do the other one. So it's done, I filed it, it's round, nothing stays out, and if I try to insert this part, it's possible. So it goes nicely inside. And you don't have to worry about the sealing, because these screws will seal the holes anyway. The sealing here on this part, you can see it's actually between the screws. So this one does not interest us, and this one will be sealed. In order to reinforce it a little more, I will apply even more glue in the groove underneath. Some on the rear. I will wipe out off the excess. And I'm gonna use my trusty old soldering iron to melt the PLA together with this plastic of the nozzle just a little bit. And maybe a little around these screws. Now again the file rounding. Make sure that when you put this part over, it can move backwards freely and forwards also freely, because when there would be some leftovers here, then this part could be caught up here and the nozzle could be blocked from going back into the bolt carrier group when it should. You might think, why do I need this plastic part? I can only add this screw here. I will tell you, I tried it and the screw got torn out and actually damaged one of the nozzles I had. So don't do it, make it this way and it will be safe. Okay, so we take these parts like this. This is the proper orientation of the silver part against this hole with the pin. The spring with NPS goes inside like this. When you have the top of the nozzle, it has to be like this. And you put everything inside. And if you do it correctly, it will close. So if something's wrong, you will not be able to reach this final position. Now the tiny pin, we took it out from this tiny hole here. Can you see it? So we push it back in. And make sure it does not stick out. One more thing you might want to do is to reapply some grease on the o-ring here on the rear part and really make sure that this whole nozzle is clean. I use some Teflon grease, is the regular one that I use for this purpose. Next you take the bolt, nozzle and this washer. You can clean the bolt inside of course and lube it properly, and you throw the nozzle inside like this. A part of it will go out of this hole on the rear, and it's tricky to put in this this tiny washer, so I do it this way, that I lift up with a screwdriver this rear part here, and when it's lifted up I push this washer with some other tools. So I try to do it, but it will be really tricky to do it on camera. I don't know if you will be able to see how I do it. So I pull this up with the screwdriver and I push this washer, which is actually a C-clip, underneath, and when it's there I can remove this screwdriver, this part won't go back inside, and I can push this C-clip into the final position. This is the easiest way, and when I pull the nozzle it should go back. And the final step is to take the top part, put it on the top. One thing, be careful, because here there are two holes for these two headless screws from the top of this part, and if you screw them too deep actually you can damage the bolt, because they will push in the surface of that cylinder for the nozzle inside. So what I do in my guns, but I don't want to do it in this video, I maybe will make another video about this, I just screw in some metal inside so that there is no hole here, and those headless screws don't push against the wall of the cylinder inside. But this is another topic, just be careful. So I'm pushing this over here. This part has to go inside, and then I'm pushing this to the maximum to the front. And what I will do now is I will push this pin back, and you don't need to heat it, you can maybe just squeeze it in. Yep. And be careful when working with this pin, because one thing, you want to make it flush on both sides so that it does not scratch on the charging handle, and you don't want to damage the bolt on those guides on the sides here and here. Yeah. Next step are these two headless screws, but again be careful. And this last screw, it had some Loctite applied, and it also has an o-ring under the head, so you may want to reapply it so that it won't fall out. And it's done. You reassembled the bolt carrier group. You want to reapply the grease on the guides here, here, here and here. Of course, apply some grease to these bottom surfaces that work on the hammer, and to this one where this lever for valve knocker works, also to the rear part. And let's see if we are successful. So if I pull the nozzle out, you can see it goes only to this length and then it goes back. I will reapply the grease, put this back into the gun and show you the effect. And now when we have the bolt back in the gun, you can see that no matter what happens, if I have the magazine in or not, when I pull the charging handle back, always when the bolt goes to the somewhere around the middle of the ejection port, the nozzle, and you can see that the bolt catch did not cut the bolt carrier group yet, but the nozzle in this phase where the bolt catch can go upwards and damage it will be safely on the other side, and the gas port will never get damaged. Again and again, and when I pull it till the end, the bolt catch goes up, and this works. I tested this as I said, 10,000 rounds without any issue, and I chronoed the gun and there was absolutely no change to the joules or the FPS, and the rate of fire did not change, and I'm able to pull out the same amount of shots from the same volume of HPA tank I used before. So it really has absolutely no impact on the efficiency of gas consumption. It only improves this damage that normally would be happening to the nozzle, and it makes your bolt catch work. This video is getting kind of lengthy, so just let's quickly check that this works as I said. An empty magazine, and let's do it. Not even a single failure. Let's try another magazine. This is number 9. That one was number 1. No problem. Works like a charm. Let's do number 3 now. With these examples you can see that the bolt catch works every single time when I shoot, and this would help exact same way regardless of you are using the HPA conversion with the 3D printed magazines from Frog Engineering, or you use the stock VFC magazines for the green gas. It's the exact same failure that happens, and the solution is exactly the same. And if still after watching all the investigation I have shared with you, you are not sure if this is the case in your gun, then just look at the nozzle if it gets worn out like I showed. If yes, then you know what's the problem. To cut it short, thank you for watching, hope you liked it. If you have any questions, then send them to me, I'll try to help. You can do this modification easily. The 3D model is in the links in the description, but you can use any piece of plastic and fit it to serve the same purpose. Be sure not to miss upcoming videos, there will be much more of modifications, improvements, HPA, GBBRs and so on. Subscribe, like, hit the notification bell, comment. May the power of GBBR be with you.